Hi, today I hope to explain how to solve some calculations by using the normal distribution. This is a simple method. And first of all, I would like to explain what the probability distribution is. So I remember you, don't skip this video and keep watching till the end. Let's go to the video and try to get some more idea about the normal distribution. Let's go. Right, I will first explain about the probability distribution. In probability theory and statistics, a probability distribution is the mathematical function that gives the probabilities of occurrence of different possible outcomes for an experiment. It is a mathematical description of a random phenomenon in terms of its sample space and the probability of events. That is a simple definition of the probability distribution. Right. What's the probability? The probability is simply how likely something needs to happen, that called as the probability. And I will take one more example to make this more clear. Right. Considering rolling a six-sided die, you have an equal probability of obtaining all six numbers on your next roll. So obtaining precisely or one of number one, number two, number three, number four, number five, or number six equal in probability of one divided by six. Hence, that is an example of a discrete uniform distribution. The several types of distributions have been included in statistics. Poisson distribution, binomial distribution, T distributions are some of them. But today I will explain about the normal distribution. Let's go and get some more explanation about the normal distribution. A normal distribution. The bell curve is a normal distribution. It is often called a bell curve because it looks like a bell. Now let's talk about the main components and characteristics of normal distribution. You can see the mean, median and mode are equal and symmetry about the center. And the 50% of values less than the mean and the 50% of values greater than the mean. And we can usually see three types of grand standard deviations. 68 of values are within one standard deviations of the mean and 95% of values are within two standard deviations of the mean, and also the 99.7% of values are within three standard deviations of the mean. So these are the main three types of the standard deviation. Alright, now I'm going to talk about the standard normal distribution. To convert a value to a standard curve called as the Z curve, first subscribe the mean. You have to subscribe the mean, then divided by the standard deviation, and doing that is called standardizing. And now you can see the differences between normal distribution and the standard normal distribution. The first graph shows before the standardizing, and the second graph shows after the standardizing. Now a little problem may arise. Why are we standardizing? Alright, I have taken an example for that. Let's go to clarify it. You can see the example. Professor Silva is marking the test. Here are the student results out of 60 points. 20, 15, 26, 32, 18, 28, 35, 14, 26, 22 and 17. Most students did not even get 30 out of 60 and most will fail. So here in such cases we have to face a terrible situation. So at a time like this we can get a good possible result by standardizing. Let's see. The test must have been really hard. So the professor decided to standardize all the scores and fail people one standard deviation below the mean. And then we are going to see whether it works or not. The mean is 23 and the standard deviation is 6.6, and these are the standard scores. You can see the standard scores which is given below. Only two students will fail. Before the standardizing we have lots of failures, but after the standardizing we have only two failures. So I think that you understand something about this. So now let's use this normal distribution and try to solve the calculation. We have the formula for calculating the Z curve. You can see the Z is the Z score, mean as the standard score. X is the value to be standardized, and mu is the mean, and sigma is the standard deviation. Right, here the formulation. Z equal to x minus mu divided by sigma. This equation or this formulation is really important to make some calculations by using normal distribution. Let's go to the assignment and try to solve some calculations by using this method. Here is the assignment. It was found that the mean length of 100 parts produced by the lathe was 20.05 millimeters with a standard deviation 0.02 millimeters. Find the probability that a part selected at random would have a length. The part 1 between 20.03 millimeters and 20.08 millimeters, and the part 2 between 20.06 millimeters and 20.07 millimeters, and the part C less than 20.01 millimeters, and final part of this assignment asks us greater than 20.9 millimeters. So they ask us to find the probabilities of these lengths. Let's go to the calculation and try to find out the probabilities of these lengths. Part A, according to the question, we have been given a value of 20.05 as mu here, and we are asked about the probability of length between 20.03 and 20.08. Here we have to standardize two values. The first of all, you can see the mu value in here, and you can see the standard deviation is about 0.02, right? Then we have two standardized values here. The first one is x1 and the second one is x2. So I name it with x1 as 20.03 and x2 as 20.08. You can see that in here, right? Let's find the value of z with respect to x1. So in there we use this formulation to calculate the z value for the x1. I mentioned that formulation earlier, so this is really important to solve some calculations by using the normal distribution, right? The x1 is 20.03 and the mu value is 20.05 and the standard deviation is 0.02. So we have the values minus 0.02 divided by the 0.02. So we have the z value for the x1 is minus 1. Then I repeat that to the x2 and find the z value to the x2. Then you can see the x2 is 20.08 and maybe it's the same number 20.05. Then I divided then both numbers are divided by the sigma. It means standard deviation and its value is 0.02. So we have the value as 1.5 for the z value of the probabilities. You can see the probability 20.03 is lower than to the x and x is lower than to the 20.08. And the same thing, minus 1 is lower than to the x and x is lower than to the 1.5. In there we want to solve for this value between these two values. It means we have to calculate, we have to find out the x value, because in that question we asked about the x value, so we need to find out the probability according to the x value. Now you can see the normal distribution curve that I created. I am solving this calculation by using one standard deviation. Therefore, the value of this entire axis can be taken as 1 using one standard deviation. So the entire axis is 1. We previously found the z values for x1 and x2. It is minus 1 and 1.5 respectively. You can see these numbers here. Right. Then we have to find the part shown by the strips between these two values. That means we have to find out the part shown by here, because we want to find the probability between these parts. Then I can find the value between 20.03 and 20.08 or the value of x after taking the sum of these two parts here. Also, I have used the normal distribution table and have taken the values related to -1 and 1.5 as 0.3413 and 0.4332 respectively. After sum of these values, we have got the value is 0.7745. Then we have to 100 pieces here, 100 pieces, and then I'm going to find out the probability of these lengths. Right, then 0.7745 multiplied by 100, and you have the answer as 77 pieces. I will explain further more about this. According to the Z table value, you can see that this part depicts 0.413 and this part depicts 0.4332. And the sum of both values we have got the answer as 0.7745. Then you can use this value and you can find out the probability by using this value. Right, part B. Again, we have to find out the probability of lengths between 20.06 and 20.07. I will do the same thing as before I did in part A. So x1 I name as 20.06 and next to is 20.07. In that occasion, we have two values to standardize. So we use the same equation. Is it equal to x minus mu divided by sigma? So the x1 value is 20.06 and it subtract from 20.05 and divided by the standard deviation is 0.02. So you have the answer. You have got the answer for the z value for the x1 is about 0.5. Then I'm going to solve the z value for the x2. The same equation here. You have the answer z value for the x2 is 1. Then the possibility is displayed here. You can see the possibility equation is displayed here. Here we are asked the probability of the values 20.06 to 20.07. That means if we take it as z values, it is from 0.5 to 1. It means we need that area to be calculated. Then after subtracting the table value from 0 to 1 and 0 to 0.5, then we can get the value from 0.5 to 1. That means we have already taken this part's value. It means 0.413 is the value of this part. And we have already got this part 2. It means 0.1915 is the value of this part. But we needed to find out this part, so we have to subtracting those numbers together and we can find out the value of this part easily. So that is 0.1498, and we can find the probability between 20.06 and 20.07 by using that value. Then 0.1498 multiplied by 100, and you have got the answer as 15 pieces there. Let's talk about the part C. Ask us to solve the less than 20.01. So there is the only one standard value here. X1 is, I name as the X1 is 20.01. So I use the equation is it equal to x minus mu divided by sigma. Then you have the answer as -2. Then you can see the probability equation is displayed here, and I already checked from the z table value, and I got the answer for the table z value as 0.4772. So that's the table z value for relative to the -2. As I mentioned earlier, the value of that entire axis is 1. You can see the entire axis is 1. Then we get two equal parts. Here you can see the equal parts of that graphs. So the value per share is 0.5. So I have taken 0.4772 relative to -2 as the table value. We are asked for the length less than 20.01. So we have to subtract 0.4772 from 0.5. Then you can get the answer as 0.0228. So that's the value, right? Then 0.0228 multiplied by 100, and you have got the two pieces as the answer here. Alright, all facts are discussed. I think you have got some basic idea about what the normal distribution is. I'll wrap up this video here. If you think this video is really interesting or this video is really nice, then put a like. And if you have any hesitate or if you have any comment, please use this comment box and put a comment into the comment box. Most importantly, if you think this concept will be very useful in your career, then subscribe my YouTube channel. I'll wrap up this video here. I'll come with a new video. Have a nice day and goodbye.